So, have you ever wondered how we make sense out of data? If you don't, then this playlist is for you. Here I'll be covering statistics that includes data science, very simply for you to understand. And this video will be an introductory video, and if you know what statistics is and how it differs from machine learning and what is the power of descriptive statistics, then you can skip to the next video. So, what is statistics? Statistics is a branch of mathematics which deals with data, and it's more like a tool that we use to understand the data. It processes the data, it organizes the data, and it summarizes the data as I have written here. So if I have a data set that contains thousands of numbers, I can't actually say anything seeing the data, seeing the numbers. So statistics is the only tool that understands that data. Statistics is the only tool that explains what those numbers is saying. Sometimes stat gives insights about the data. Stat tells us what the data is saying, and sometimes it gives prediction out of the data. Sometimes it tells us what the future beholds. And statistics is used almost in every domain of the world, in medical, in weather forecasting, in business. If I see how statistics differ from machine learning, in statistical world, first a problem is formulated, and then the statisticians is told to get the data and resolve the problem. Statisticians actually get the data for that problem to solve. And on the other hand, in machine learning, data is given before and problem is after. The machine learning engineer is asked what the data is saying. In statistician's world, the data is more important. And in machine learning world, how you are asking the questions to the data is more important. In statistical world, the data is rich, and in machine learning world, the problem is rich. And this is how statistics and machine learning differs. If I see the branches of statistics, then there will be two. One is descriptive statistics and one is inferential statistics. To explain descriptive statistics, as its literal meaning is saying, descriptive statistics actually describes a dataset. To explain this with an example, if I see a 2-minute summary of a 2-hour movie, then I can explain what the story of the movie is, who are the actors, and what the starting and ending of the movie. So I don't have to see the whole movie to tell what the movie holds for us. So descriptive statistics actually does the same, but it does it for the data. It explains a huge number of dataset. It explains a dataset that contains thousands of numbers in 3 or 4 numbers. Let's say I have dataset that contains thousands people's age, and if I see the 1,000 numbers, then I can't say actually anything. But descriptive statistics takes 5 or 6 numbers out of those 1,000 numbers. Those 5 or 6 numbers explains the whole dataset of age. Descriptive statistics actually summarizes the data. It describes the dataset. And on the other hand, in inferential statistics, before understanding, I'll have to talk about one small topic, which is what is population and what is sample. To explain this, let me give you a problem. Let's say I'm a football fan and I want to know about a particular football team's popularity to the whole football fans of the world. Let's say this is the whole football fans of the world. To understand the popularity of that particular team to the whole football fans of the world, I'll have to reach to the whole football fans of the world. I'll have to reach to each and every one of the football fans. So it's actually not possible for us practically. We can't actually reach the whole football fans of the world. So what we do is we take a small portion of the fans of the world, let's say this, and we analyze, we survey on these small numbers, and after surveying we see what this small numbers is saying about that particular team, and after that we use the survey to predict what the whole football fans of the world is saying about that particular football team. This is called inferencing. And the whole football fans of the world in statistical language is called population, and the small number that we surveyed on is called sample in statistical language, and the survey we use to predict the whole population is called inferencing. And inferential statistics does inference. It uses probability to predict, and here we use the prediction and stuff we'll be seeing in later. So as we are dealing with statistics, we'll have to deal with data. We'll have to know what are the types of data that we'll have to deal with. There are actually two types of data we know. One could be number and one could be non-number. So number will be saying this numerical, and that non-numbers data will be saying this categorical. The numerical data are also divided in two types. One is descript and one is continuous. Discrete is more like lumps of numbers. There is no connection in between to go from this number to this number or come from this number to this number. It's if I give an example, let's say I'm rolling a dice and taking numbers of rolling a dice in one time. So what will be the numbers? The numbers will be 1, 2, 3, 4, 5, 6. These are the numbers that I'll get rolling a dice one time. So I won't be getting any numbers in between 1 and 2. I'll be getting 1.2. I won't be getting 3.7. It's just 1, 2, 3, 4, 5, 6. There's no in between. So these are called discrete numbers. And continuous numbers is the opposite of discrete. There will be in between numbers. There will be 1.1. There will be 3.7. If continuous is 1 to 6, then the numbers will be anything from 1.000001 to 6. So the other type is categorical. Categorical is two types. One is nominal, one is ordinal. Nominal means names. So categorical is non-numbered values and nominal means names. So in nominals, the data are names. It could be a data of a list of fruits. It could be apples, it could be bananas, it could be orange. And in ordinal, these are also names, but in here there is a sense of order, like good, average, bad. We can see there is a sense of order. If this is 1, this will be 3, and the average must lie in between. This will be 2. So there is a sense of order. So this was my introduction video about statistics. In next video, I'll be covering the next topics of statistics.